This is the world's first sand battery. It's filled with 100 tons of sand. It can harness renewable energy, storing it as heat. And there are more in the pipeline.
We're going to build here a largest sand battery in the world.
The sand battery is just one of a handful of heat batteries on the market.
If we want to use renewable energy when the sun isn't shining or when the wind isn't blowing, then we need to have it stored somehow.
We're looking at some simple earthy materials, harnessing energy as heat, on this episode of Transforming Business.
This one here is the center point of the sand storage.
This is the site of what will be the world's biggest sand battery.
It's about 13 meters.
It'll be taller than its neighbour, a wood chip burning plant here in the small town of Pornainen in southern Finland.
We are trying to replace here about 60% of our district heating produced with the wood chips. And the sand battery is able to do that.
That's Mikko Pajanen, head of a Finnish district heating company that's invested in the sand battery technology. It's building the battery to store renewable electricity as heat. When needed, the heat will then be fed back into Pornainen's district heating network. 2.5 hours drive away in the west of Finland is the first sand battery ever built. It's 10 times smaller than the one to be built in Pornainen. It's a 4 metre wide, 7 metres high steel silo with 100 tonnes of locally sourced sand inside. That's about the same weight as a blue whale. Sand is used here because there's lots of it in this area. Sand is made up of lots of small particles with a large surface area, and because of this, can store heat very well. Think of being on a beach in summer and how hot sand can feel underneath your feet. The battery stores electricity in the sand at around 500 to 600 degrees Celsius and can store it for weeks or months at a time. The sand used in this is low grade and not suitable for construction. The company behind the technology is Polar Night Energy.
We use electric resistors to heat air, which is circulated through the sand, and then when the air is hot and the sand is cold, the heat is transferred from the air to the sand and then it's stored there.
When the heat is needed, it's released. This sand battery is connected to a district heating network and heats homes in the area. It even heats this local 25-metre swimming pool. In a world driven by renewables, one study suggests that by 2040, storage solutions like sand batteries will be able to store and supply up to 15 times more energy than today. Otherwise, with too much wind and solar power, this reported situation in California might be repeated the world over.
There is so much solar energy on the grid that electricity is sometimes actually being thrown out because of it.
Renewables are intermittent. When the sun is out or the wind is in full force, there's lots of electricity being made. The trick is to capture that energy when it's plentiful and not waste it, and to channel that energy to people when they need it. World governments have agreed to triple renewables by 2030, and that's why we need large stationary storage solutions. Thermal batteries are said to be more suitable in holding large amounts of energy, last longer and are cheaper compared to lithium-ion batteries. They don't need rare minerals. So just to recap, in a thermal storage system, renewable electricity can be used to heat up a material that's especially good at capturing heat and surrounding it with insulation to make a sort of giant thermos. A number of companies are playing with natural materials for this.
We make individual bricks that are half a ton that each of them stores more energy than the battery pack in a Tesla Model X.
That's John O'Donnell, head of Rondo, a company that makes bricks from clay that function as heat batteries for industry. Like the sand batteries, the bricks store energy as heat to be used later as heat. But unlike the sand battery, the technology used for heating the bricks can also convert the heat back into electricity. The bricks can store energy at a much higher temperature than the sand battery, almost 3 times as high, at 1,500 degrees Celsius.
And because Rondo provides the hottest thermal storage that's in commercial operation. Today, only our technology can repower coal-fired power stations at their original turbine efficiency.
The brick is used in packs for industrial processes, and Rondo says a single heat battery saves more carbon emissions per year than 8,500 Tesla electric vehicles. A report published earlier this year said that electric thermal energy storage solutions could reduce up to 2% of energy-related greenhouse gas emissions by 2030 and up to 14% globally by 2050. And it's not just heat batteries made of sand and bricks, but rocks too. These large stationary batteries made by Bren Miller are filled with crushed rocks and are already connected to serve the needs of a hospital. They have a lifespan of 30 years.
I think rocks have a lot of potential because they're natural, they're abundant, you have them as a byproduct quite often, and they have some nice thermal storage properties that make them attractive.
Bren Miller is one of the older companies doing heat storage. They are driven by harnessing green energy, but their primary drive is to make the process of making heat less reliant on fossil fuels, especially for the industrial sector.
Heat generation or heating and cooling is over 50% of the energy we consume in the world.
That's Doran Bren Miller, Chief Business Officer of the company.
In the industrial sector, the numbers are even higher. It goes up to 60-70% sometimes, the emissions that are used to generate steam or heat.
This is a crucial point. If thermal energy storage solutions can help decarbonise industry, we're more likely to have a healthier planet. And we'll go back to it later. First to Chile. This solar field covering 700 hectares has 10,600 heliostats and a 252-metre high tower. This area has some of the highest levels of solar radiation in the world. The plant has over 17 hours of thermal storage capacity using molten salts.
During all the hours of sunshine, we store thermal energy, that is, storing salt at 560 degrees Celsius in a very large tank.
The solar power is captured through the heliostats or mirrors. These reflect the sun's rays to the receiver located at the top of the tower. There the radiation is absorbed, heating a stream of cold molten salts and converting the energy back into electricity to be used when needed.
We are an electrical storage plant that with sunlight can generate electricity 24 hours a day. This means that you can feed a city like Calama, which is our neighboring city, and we have enough capacity to feed the city of Calama 24 hours a day.
Thermal batteries are especially useful as the planet weans off fossil fuels. Remember how the renewable energy harnessed by the sand battery warms the swimming pool in Finland? But why is it important to talk about heat? According to the International Renewable Energy Agency, heating and cooling make up half of the world's total energy consumption, significantly more than electricity and transportation. This heat amounts to about 40% of energy-related carbon dioxide emissions. In industry, heat is the central driver. For example, in pasteurising food to preserve it, produce like milk is treated with mild heat, usually less than 100 degrees Celsius, to eliminate pathogens and extend shelf life. At the higher end, steelmaking, for instance, requires heat at 1,600 degrees Celsius. Fossil fuels currently drive most of this. But thermal batteries are already stepping in instead.
And the faster we can deploy wind and solar and put it to this purpose, we can build a future that is lower cost, that is not volatile in price, and that is zero carbon.
There is a caveat, however, to thermal batteries as we now know them. Let's look at the sand battery first. This one loses about 30% of its energy and is not yet capable of returning electricity as electricity, but as heat, as we've discussed. And the battery can only be applied to less than 40% of industrial needs because of its lower temperature range. It's also worth remembering that sand, though plentiful in this region of Finland, is a finite resource, and ungoverned sand extraction is driving erosion, flooding, and the collapse of coastal defences. Which is why the team in Finland are exploring sand-like materials. For the new sand battery, crushed soapstone, a byproduct of a Finnish company that makes fireplaces, will be used as the storage medium. With the bricks, while they can convert the stored energy into both heat and electricity, there is a carbon cost associated with making them. But Rondo says the battery cancels out the emissions generated in making it in its first month of use. Because of the heat of the bricks, the company claims they can be used instead of fossil fuels in 90% of industrial processes. The use of molten salts, meanwhile, to be used for storage, need a lot of energy to be kept hot. Think back to the plant in Chile, one of the places on the planet with the highest levels of solar radiation. Rocks, on the other hand, while they're not capable of storing heat as high as the bricks, and therefore not as impactful in tackling industrial heat, they are plentiful.
So in many ways, these rocks are more or less free and have very, I would say, minimal environmental impact.
Whether it's sand, bricks, rocks or salt, thermal energy batteries mark another step forward in the move away from fossil fuels.
We are entering an era when the sustainability officer and the financial officer can love each other.
What do you think of thermal batteries? Let us know in the comments below. And if you liked this episode, please check out the Transforming Business playlist for videos on topics just like this one.